Okay, now we're going to look at my heart over here. And we've already talked about electrodes, so I've got a positive electrode here and a negative electrode here. This is the base of the heart, okay, so the top of the heart, and the bottom half is the apex of the heart, okay? So the top of the heart and the bottom of the heart. We've got a positive electrode and a negative electrode. I want you to think of it like the positive electrode is on the hip since it's on the bottom, and the negative electrode is like towards the head, okay? So let's talk about the electrical impulses and how they travel through the heart. First, you got your SA node. That first little green dot up here is your SA node, okay? Your sinal atrial node. And let me just kind of pull this over a little bit so you can see. Okay, so here we go. And now, so what's going to happen, and I'm going to use words like action potentials, and action potential actually just means the electrical activity in the heart, the depolarization and repolarization. Depolarization is the contractibility of the heart, like the heart at work. Repolarization is the heart resting. Okay, so we're talking about the heart contracting and resting, contracting and resting. Depolarization, contraction, repolarization, resting. Okay, so when I talk about the vectors or the mean vectors, I'm talking about which way the directional term of which way the arrow, like I was showing you here, is going to go. Are we going to have a positive deflection? Are we going to have a narrow deflection, which is a positive vector, or a negative vector? Okay. Also, we're going to talk about an isoelectric line. But right now, we're going to talk about action potentials, in which we talk about what's happening in the cells. And let me just go back to an earlier lesson when we talked about the cell activity and what makes things positive and negative. Well, remember, sodium is positive, and it's an ion. And then we have potassium. And then we have calcium out here, and they kind of make the travel back and forth. Kind of, it's like your negative and your positive and your in between. So this is calcium. All right, so anyway, when the cell is positive, it's going to contract. And that's when we have that good old sodium or salt in there. And then, now potassium is a weaker ion, and that's going to become negative. So this is when it rests. So all day long, we have a flipping back and forth of contract and rest, negative to positive, okay? Erase that. And we're going to go back up here where you have the SA node. The SA node's impulse is going to travel. It's going to go this way. It's going to come down here. And this is the Bachman's bundle. It's going to contract the atria here. And since we have the atria, remember, turning positive, the cells are turning positive. That means we're contracting. That means we're going to get, and look where we're traveling to. This impulse is actually traveling to, yes, the AV node. But it's traveling towards, the impulse is traveling towards what? The positive electrode. So with that positive electrode, you are going to get a positive deflection. And this positive deflection is called the P wave. So the P wave represents atrial contraction. What does that mean? The atria is working. It's not relaxing, it's working, it's contracting. So what happens when you squeeze a sponge? All the water comes out. So when when the atrias are squeezing, it's pumping that blood where? That's right, into the ventricles. Squeezing. This is my squeeze mode here. squeezing. The heart is working. P wave, atrias are squeezing. They are working. Okay? Which represents a positive deflection because the impulse is traveling towards the positive electrode.